Today we're going to talk about something we've mentioned briefly, but we're going to start talking about some of the objects in our solar system. And today we're mainly going to talk about planets. We're going to talk about the biggest part next to our sun. The word planet has come to mean a lot of different things over the years, kind of like an evolving definition. But the word itself comes from a Greek word, planetes, which means wanderer. And so they looked in the sky and they saw these objects moving across the sky or wandering across the sky, and they gave it the term planetes, which is where we get our word planet. So let's look at our textbook definition of the word planet. Today, a planet is an object that orbits the sun, is large enough to be nearly spherical in shape, and has no other large object in its orbital path. Now, in history, lots of things were counted to be planets that are not planets today, that we know they're not. The sun was counted as a planet, the moon was counted as a planet, a number of different asteroids and dwarf planets and things like that were considered planets. And even up until modern times, obviously we know that the sun is not a planet, and we know that the moon is not a planet. But there were a lot of different objects that were considered planets up until fairly recently. And this happened a little bit before your time, but I can definitely remember it in 2006. There was kind of a small uproar in the scientific community because the International Astronomical Union revised its definition of a planet. And they said a planet is a celestial body, which, first of all, is in orbit around the sun. Number two, has a sufficient mass to assume hydrostatic equilibrium, meaning it has a nearly round shape. And then three, it has cleared the neighborhood around its orbit. We talked a little bit about this, meaning that it has no other large objects in its orbit. It has either absorbed them into its own orbit, but it's not sharing an orbit with anything like that. So, we can think that we had a pretty modern definition because we said, well, the sun, that's a star, and the moon, that's a satellite. And certain objects, well, those are asteroids and these are comets. But this changed things in the way we understand planets. When I was growing up, we had a mnemonic device to remember the planets. There were a few of them. The one I can remember the most is my very eager mother just served us 9 pizzas. So meaning Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, Uranus, and Pluto. Well, according to this 2006 definition, Pluto is no longer a planet. And so that, was kind of a big deal in the astronomy community. It didn't really change my life, but it changed what I knew about the solar system and what I knew about a planet. And so that's the accepted scientific definition of a planet. So a lot of these things that we look in the sky or we look at pictures and we think, oh, this must be a planet, it's no longer considered a planet anymore. So with that definition in mind, let's look at the types of planets that we actually find in our solar system. The first is what's called a terrestrial planet. Terrestrial planet. So a terrestrial planet is a planet that's like ours. We live on a terrestrial planet. It's a body largely composed of rock. So the terrestrial planets are Mercury, Venus, Earth, and Mars. Let's look at kind of the way they're made up because they have a similar makeup. So you have a solid inner core, often a liquid outer core, and then your mantle and your crust. But the important part is this core. They are made of very heavy elements, most likely iron, something very dense, and that is what's giving the planet most of its mass. That's what's causing the gravity. And so you have that surrounded by a silicate mantle or something like that, and then our rocky crust. And these terrestrial planets have surfaces that have mountains and ridges and valleys and craters and all kinds of things that we see on the four that we know of. The second type of planet is a gas giant. Now, a gas giant, like it says, is a giant, but they're mostly composed of hydrogen and helium. And sometimes they are known as a failed star, because if you remember back when we'll talk more about this in the next unit or next lesson, but stars are powered by the fusion of hydrogen atoms into helium. And so when you have an atmosphere of a large body in orbit, that could have ended up as a star, but it did not. So these have they're thought to have an outer layer that is, let's pull this up here, an outer layer that is mostly molecular hydrogen, and then it surrounds that's like a gaseous hydrogen. Then it surrounds an area of liquid metallic hydrogen, and probably has a molten rocky core. The outermost portion of their hydrogen atmosphere would be made up of all kinds of layers of visible clouds. You look at Jupiter and Saturn; these are our local gas giants, and you can see the storm on Jupiter, the big spot there. These are visible clouds and most likely made of water and ammonia. But then there's this layer of metallic hydrogen, and that's really what makes up the bulk of the planet. And it's there's a lot of chemistry and physics that goes into why it's referred to as hydrogen, which we're not going to really get into. But the cores of these gas giants would be made of heavier elements, and they would be at very high temperatures and have very high pressures. So we don't really understand a lot about what it's made of. We haven't been there, we haven't seen it. So this is just our best speculation on it. Then we have what's called the ice giants. An ice giant is composed of mainly low boiling point materials like water, methane, ammonia, and then it'll have a very thick atmosphere of hydrogen and helium. And so there are some similarities to the gas giants, absolutely. But they're these kind of what we call volatile compounds, and meaning they have these freezing points that are above a certain point. Like water, we know it freezes at 0 degrees Celsius or 32 degrees Fahrenheit, and so it's mainly going to be made up that, and it's distinct from a gas giant because it has all of these ice layers. Now, let's talk about, it would have an atmosphere. Let's see if we can pull up. This is Neptune. So it would have an upper atmosphere, has these clouds that we can see, but then it'll also have a lower atmosphere, like I said, made up of hydrogen and helium, methane. It'll have kind of like a mantle. This is where all of your ice is, the water, the ammonia, the methane. Then it's thought to have a solid rock core, something that's giving it this density, that's allowing it to have mass and the gravitational pull that they have. I mean, if it didn't have something solid in it, something very dense, then it would be hard for it to have a gravitational pull as strong as it does, to have moons and things like that. So these are our three main types of planets. But now let's talk about a dwarf planet. Whatever happened to Pluto when it got downgraded so it's no longer a planet? Well, what in the world is it? It's a dwarf planet. So the same committee that defined planet in 2006 also defined dwarf planet. So here's our vocab definition. Dwarf planet is an object that orbits the sun, is nearly spherical in shape. So far it's sounding very similar to a planet, but here's the thing. It shares its path with similar objects. So let me show you what the International Astronomical Union said. They said a dwarf planet is a celestial body, so far so good, is in orbit around the sun, yes, has sufficient mass for its self-gravity to overcome the rigid body forces so that it assumes a hydrostatic equilibrium. Remember, that means it has a nearly round shape. But here's the thing, it has not cleared the neighborhood around its orbit. There are other things that share that particular orbit, and it's not a satellite. So it's not a moon, it's not orbiting a planet, it's still orbiting the sun, but it's not a satellite. So here's where things got tricky for Pluto. So yes, it orbits the sun. Yes, it has sufficient mass to be nearly round in shape, but it did not clear its neighborhood. So let's look at what are the 5 known dwarf planets in our solar system. So here we have Pluto, that's the familiar one. There's also Ceres, Makemake, Haumea, and Eris. Some of these were thought to be asteroids at one time. Some of them were thought to be moons. Pluto was thought to be a planet, but since we have this definition, and we'll talk more about objects that are in what's called the Kuiper Belt tomorrow, but these dwarf planets, some of them actually fit in there, some of them fit in the asteroid belt. So that is planets and dwarf planets.